I imagine there'll be some noise as people filter in, but the first couple slides are sort of introductory anyways. So thanks for those who are here. Going to talk about Postgres and Power and how that all works, at least a little bit. So first introduction, I'm Robert Treat. I run the US team at Credativ. I'm recognized as a Postgres major contributor and have been doing Postgres since 1998, so since the last century. Yes, that's a very long time. You can find me on Twitter at RobTreat2. If you want to contact me for any reason or get slides or something after that, that's probably the easiest way to do that. I definitely want to sort of thank or acknowledge work. So this talk is about the work of a number of different people who've worked on Postgres and Power at Credativ, and I'm the lucky one who gets to stand on stage. I would be remiss, though, if I didn't thank Bernd Helmle, who has done quite a bit of this work for years now on Power, and has probably our deepest amount of technical knowledge on Power itself since he's been involved with the project. So he's been at Credativ also a very long time, has been a technical lead on much of the work that we've done over the years, has been involved with Postgres since, he's a newbie, relatively speaking, because only since 2002. But you can also find him on Twitter, and he would be more than happy to share and discuss as well. So I just wanted to give a shout out to him. To understand what Credativ does, just sort of a quick overview, we are a services and support company for open source projects. Postgres is one of our major pieces. We also do a lot of work in the Debian community, which will be important later. And we just sort of put those things together and help companies who are trying to leverage open source for different business purposes. Jumping into the Postgres part of this, I assume most people have some familiarity with Postgres, but maybe not deep understanding. So Postgres, for those that are unaware, its university roots actually come from Berkeley, California. Actually in the early 90s is when the project was started at the university. And around 1995, it was launched and sort of made open source and given to the world. So it came out of university. And it's been developed more or less continuously ever since then. So now over 20 years of development in the Postgres project. And so you can imagine it's quite a bit different now than it was 20 years ago. There's been a lot of work that's been done on that. We just actually released Postgres 12 in the early part of October. There are about 400 contributors to that release. So that shows a pretty active development community, especially I will say our development process is pretty thorough and rigorous, and some might say cumbersome to get through and get patches in and review and all that. So it's not quite as easy as thumbs up emoji on GitHub, but we still managed to get a pretty large contributor group. So we also support Postgres is pretty much everywhere these days. Obviously on-prem it's database stuff, so people run it on hardware a lot. But every cloud service has a Postgres offering, except maybe Oracle, I guess, doesn't, but Microsoft does, and Google and Alibaba and all of these companies have that. And people are doing it with containers. We see people using Postgres in the embedded space. That's an interesting one because it's not really designed as an embedded database, but not sure it's designed for Kubernetes either, but we'll make it work if that's what we have to do, So. And also, again, used in all industries. If you're wondering what is the footprint of Postgres, pretty much any industry you can imagine. It's at the point now where, if you traveled here from someplace outside of the city and you weren't walking, you probably use some service provider or company that uses Postgres somewhere. It's that sort of widespread as far as databases go, and certainly on the relational side. So. Another thing that's sort of important to know is that it is a true, real community-based project. So there's no single entity that owns Postgres. It's not, MySQL is sort of the popular one that people can think of. There used to be this MySQL Inc. that's now owned by Oracle, and they make the MySQL database. In Postgres, out of those community and university roots, there's just a number of different companies. Credativ is one of them, but there are probably about 10 other companies that have multiple full-time people who work on Postgres stuff and that kind of a thing. So There's no single owner, but it really is driven by the amount of effort, information, and sort of demand for certain things. So that's sort of how that works. Each year, so I mentioned we just did Postgres 12. The basic philosophy here is we do about a yearly development cycle, so expect Postgres 13 somewhere in October or November of next year is when it should come out. The process is mostly like 7 bi-monthly things that we call commit fests. There's always some activity in the main tree going on, whether it's features or bug fixes or whatever. But about every other month for the next like 6 months now, there'll be these periods of time where we're doing commit fests, where we're looking at the open patches, seeing what is out there, looking at how 12 has impacted things, and then making sure they all get committed back into the tree. One of the things that's really crucial, especially if you're looking at Postgres and the power situation, we have an automated build system that, like many things in the Postgres world, like was built essentially by the volunteers of the Postgres community. If you go to buildfarm.postgresql.org, you'll see all of the systems that are listed there. And basically anybody can stand up their own automated build member. It's just a matter of there's some code you have to download and have a machine that can then do git pulls and do the compiling and upload the results back into the farm. And so because of that, we actually have very good support. I mean, Postgres, and I think this is sort of because it was university originally, it had sort of odd platform support that maybe you wouldn't have otherwise seen. It wasn't tied necessarily to what's the best commercial market. It was really, we want this to work across Unixes and be POSIX compatible and all of that good stuff. So it does work on a number of different operating systems, and you'll see those in the build farm. I did a look just to see, there are about 30 members who are running some type of Power architecture. Most of that is Power 7, 8, or 9. There's a couple of other things that are in there as well. And amongst those Power machines, there's a mix of like GCC, there's IBM build tools, so there's some that are Clang, there's some that are Debian, there's some that are Red Hat. Like it's just a pretty decent mix by a number of different people and companies that are doing that. So that keeps it pretty honest, because essentially every commit that goes into the Postgres tree gets farmed out to these members. So if there is something that is odd about, whether it's architecture or operating system or whatever, it can trip a breakage in that, and then any developer can see that and immediately try to address that situation. So we get pretty good coverage that way, which is really useful. Certainly when you're trying to work on, what may be a more niche type of system. Again, so I sort of touched on this, there's a bunch of different aspects that make up that Postgres community, right? There's the developers who are, sort of volunteers, but now mostly are paid developers. There's the tooling around Postgres. So there's the server itself that you would install, but then there's all kinds of things, whether it's backup tools or GUI admins or whatever, right? All kinds of things like that. And there's different places you can find those. Postgres also, maybe famously a little bit for the number of forks that are out there. As a good example, if you look at something like Amazon Redshift, right? It's data analytics in the cloud is how they sell that, but the history of that is actually Postgres. I don't know, I think it was about 10, 15 years ago, it was like Postgres 8.2, I think, or 8.3, was forked to a commercial company. They forked Postgres, made a thing called ParAccel, which got bought and sold by 3 or 4 different companies, which then got sort of acquired-ish by Amazon and turned into Redshift. So there's a lineage there, and the lineage of Postgres goes all over the place. There's all kinds of databases that have been built on it and use part of it. Most of that, I think, is we have a pretty liberal license. It's sort of a BSD style license. It's not officially a BSD one, so it's actually the Postgres license, but it's based on that BSD philosophy that you can use this for commercial or not. You can fork the project and put it under your own license and whatever. So we see companies do that a lot. That does lead to some confusion in the market. So going back to the Amazon example, Redshift is, I think everyone would certainly see that as a proprietary database. What they don't necessarily see is like Amazon Aurora, which they market as Aurora Postgres, is essentially a fork of Postgres where they've rewritten, into the POSIX layer how it works. So, but at the user level, works just like a regular Postgres. So if you build something on there, by and large, you would expect it to work on any Postgres, even if you change the architecture entirely. That's something worth keeping in mind. Again, as you go to interact with the community, remember it is really a very large community, but made up of a lot of different pieces. So speaking specifically about power, so why would we care about Postgres? Why would we care about Postgres on power systems? Why is that a thing? I pulled out some choice quotes that are here. These came from Computer Weekly, and I actually saw, if I'd have gotten this earlier, I would have taken the photo, because on the IBM booth outside, if you saw, like, it talks about this idea that the power architecture is really good for doing data crunching and analytics and that kind of work. And so if you're going to use a database, a lot of what you're going to do, data crunching, analytics, that kind of work. And so it makes for at least the idea that, like, oh, maybe this is the thing we should look into. And we know that Power traditionally has run proprietary database systems, right? So if you're looking at OpenPOWER and thinking, I'd like to use this architecture in a more open way, the software, you want that to match the hardware and that kind of thing. So does Postgres make sense in that context? And so when we approached this, we've been working with this for a number of years now. And we looked at this as like, okay, how do we make that leap from running Postgres on traditional quote unquote architectures and doing it into Power, and how would that work? Since we have pretty deep ties into the Debian system, we've been doing Debian support for, I don't know, more than 20 years now. So we looked at Debian and said, is that ecosystem maybe the one to lean on to see if we can do that? And I won't go into all of these pieces, but if you're not familiar with Debian, so basically all the open source projects, right, start in the top corner, and there's a little Postgres in there, but everything else, and that's those open source projects are building stuff which just filters through the system, gets experimental, and then slowly gets more stable as you move towards the other corner. And depending on where you are in the grand spectrum of things, you pick the Debian version that's right for you. But the important part is that it's a very large ecosystem also with, I don't know, there's probably maybe 100,000 Debian developers and users out there that are doing packaging and builds and all of that type of thing across different architectures as well. So we know we could leverage that. And so we did that. We also do a lot of the work for Debian itself anyways, right? Since we're big Debian supporters and we're big Postgres supporters, we're deeply involved in doing packaging for Debian and having that out there. And the Postgres project itself, having a very sort of, non-commercial roots in its community, has been big fans of both Debian and Ubuntu as well. So they are pro sort of that packaging in some ways, making sure that it works well. And in fact, Postgres has its own apt repository. So you can get Postgres through your traditional, Debian sources and get those packages, or you can get packages directly from Postgres that are in the right format to do that, right, for both Debian and Ubuntu, and for other systems as well. In this case, though, since we're deeply in the middle of that as Credativ, then I know that, like, the people who are working on that, they're not all the same people between these two, but, like, there's a Venn diagram, and most of them are the same people. So it works pretty well in conjunction. And so, like I said, you can get pretty much any active version of Postgres will be on any version of Debian and be able to get there. But you can get that directly from Postgres, which is what usually is recommended to do. Again, thinking about the whole problem, and this is where it does get tricky because it does depend on how you want to approach this. Maybe that's not the right OS for you. We like to use it because we knew it pretty well. The numbers game is definitely real when you start thinking about different versions of Postgres that are supported. Typically, the project supports about 5 different major releases, so that's going back about 5 years for major releases that'll be community supported. As a service provider, we have customers that run older things in that we have a weekly call to discuss why they should upgrade, and it doesn't happen, so we keep supporting it, and that kind of a thing. But thinking about all the different Debian releases and a bunch of releases, the Postgres releases that you have going, servers and extensions, modules, all of those pieces across different architectures, and there's a lot to potentially manage there and to sort of navigate your way through. And so we're aware of that, and it's just be aware that, like, you're going to be picking things as you're going through here. There are a lot of options, but that also gives a lot of flexibility. So it's probably a thing that can be made to work, even if it might be overwhelming at first, or you might wonder, do they really support this? There's a good chance it does. For us, so we've got some benchmarks I'm going to show you just to get an idea of what's going on. This is basically the first set of benchmarks we did. We looked at these different options. So Linux, we said we'll do it on Power, but we're going to do it on Linux on Power because we know that's easier. That whole universe, and I said like the tooling and all of that stuff, it's about 2,000 packages that are out there. So it's widespread. Now, most people probably pick like 20 packages that they actually interact with, right? But then you get into all the things like, oh, if you're doing, healthcare, there might be some Postgres healthcare modules that you want, and so you pull those packages in or whatever, right? So there could be all different kinds of things. Also depends on how your team is, right? Do they want to do a desktop GUI that they download, or do they run that through packages, just whatever. So there's a lot of packages out there that you have to choose from and be aware of and all of that stuff. So that's what we did. And again, we use typically the apt repository because we're on Debian and Ubuntu. There is a Yum one that Postgres also has available, which is for CentOS and RHEL. We used from that as well for some of these things that we tested. You may ask, just sort of looking at these, so the PPC 64LE, why are we looking at those specifically? Why Little Endian? So what we found, at least looking at this, and this is maybe geared a little bit towards a couple of years ago because this is starting to change somewhat, but we had sort of broader adoption within the open source community on Little Endian. So that's sort of what drove us in that direction. That most places already supported that, right? Whichever community, if you went into Fedora, like they already had that support. And I think it's mostly just those machines have been easier for people to get access to, right? And so that's what opens the doors to getting it built that way. And so for us, like even Docker works on Power, right? If you have it in the right operating system. So we looked at that and said, okay, let's look at that. There is a question of Power versus OpenPOWER, and like, is this a big difference? Does it even work? That kind of a thing. And I do sort of feel like all benchmarks secretly have an agenda to them, right? And so here we weren't really thinking of a versus mentality. We were thinking more like, does this even work? Would it be interesting to look at? And that kind of a thing. So just some quick specs on the machines for this. This is the first set of benchmarks that we kind of ran because we wanted to get some public information out there. So an OpenPOWER machine with 8 CPUs, and you can get the details later just for sake of time. A note on this for OpenPOWER, use the Opal boot firmware. And so we did do some sort of tweaking, and this stuff is publicly available as well. And so we did that to look at it. Comparative box, so 4-socket, 8 cores on 20 gigabytes of RAM. One thing just to call out, this SMT thing, like what is that? So if you're familiar with this, on the Power side, people probably are. When we talk with, people maybe who are Postgres users that are looking at Power, they're like, what is this all about? And this is sort of an important thing because hyper-threading and parallelization, I think, are parts of the industry that are not terribly well understood, but understanding that this architecture has some different kinds of support for that type of thing. And so we also wondered, like, does this actually matter, or do you get a benefit from it? Because that's part of what you expect to get. And so, okay, the other thing we did, we used a thing called PGBench. So if you're not familiar with Postgres, it's basically, think of like an Apache bench, but it's like a benchmarking tool that runs some basic database statistics, and then it'll do queries and whatnot, and you can get performance based off of that. And so it's used in the development process for Postgres for performance tuning and whatnot. So we used PGBench for most of what we did. And so the first graph, we actually have graphs. So here we're scaling reads, and this is just a read-only test. It's probably like the most basic test that you really would run that has database interaction. This was OpenPOWER versus the E850. And so the blue line is the OpenPOWER, right, on an 8-core machine. The red one is the 850 single socket 8-core. So it's relatively, similar hardware profiles. And you can look at that and see like, oh, yes, we actually do get pretty good performance based off of this, right? And again, since this is select only, it's not testing, the I/O subsystems and that kind of thing. It's not really thrashing it. So you get really big numbers on the transactions, and it looks really nice. And for us, the main thing was like, okay, we're actually getting numbers that look like this is a thing that should be explored further. That was sort of our first initial thoughts. You also notice, because this benchmark I mentioned, I think, was done in 2017. So it's a few years old. So we use 9.6 as the Postgres version. There have been now with 12, so it's 4 releases old on that version. So you might see different numbers if you did it with a newer version. And I have examples of that I'll show you momentarily. So again, here's just sort of a different view of it, looking at read-only scaling, simple selects. And again, what you want to see, here we're able to look at, from the 8-core machine, sort of the most important part, the yellow, right, is the 28-core E850. So you can see as it scales up on cores, because this is also a big thing that's been an issue in the Postgres community, is multi-core support as you get to bigger and bigger machines and that type of a thing. So, and we can see that we can actually take advantage of that on this architecture as it's available. So here's another one. This is going back and looking directly at that SMT support, and just looking at like different levels of threading. And for the most part, we saw, if you're only at the first level, right? So you're down here, it sort of gets better, but up at the top between level 4 and 8, it's like you're not getting that much more benefit. You do see some sort of initial benefit, and it is better in the long run, but the gap is starting to narrow there as to how much better it is. And that's probably to be expected because, again, now you're talking, if you really want to get into tuning that stuff, it's just more work to tune it, and probably you have to start looking at internals and really thinking about how to make that work better. And so here's another one, just sort of a similar test. Here we wanted to look at, would it make a difference on different versions? And so because this is a couple of years old, we had to go back to older versions here. So it starts at 9.6, and 9.6 was the best, which is what we'd expect, and the older the version, the worse it was. That's probably more attributable just to performance improvements in Postgres as opposed to anything specific to this platform, right? So keep that in mind. But that's an important thing to realize, that as we are making improvements in Postgres, you're getting those for free regardless of the platform you're on, right? So even if you're on Power, you can get that to be better. I'll also note, so we did want to also look at the IBM Advanced Toolchain. Does that actually make a difference, or how much of a difference does it make in the Postgres world? So we did take a little bit of a look at that. And here's what you see as a difference. And actually, it turns out it's like, it's not a huge difference here, right? As you scale it more, like you do get better performances, which you would expect. But between the two, there's not a giant difference. And I think usually what we see in most cases, because we do different compilers and across different operating systems, it definitely depends on how much time is somebody spending working on those specific issues to get advantage of it. And of course, because we're talking about IBM, we also said, what about AIX? And we did a little bit of testing on that. So here we're looking at AIX 7.1, again with 8 cores, to try to keep it in the same level. Was kind of a difficult test, so I don't take this to the bank necessarily, but there's some info here. So we used GCC for this and did some tuning, some specific tuning for this platform, a little bit to try to make it fair. I'm not sure that we accomplished that because I don't think AIX is this bad, but the benchmark numbers came out really awkwardly. So the blue, is wildly different here, and the blue is the Linux versus red, which is AIX. So I suspect, I don't know, I've done other things that are non-Postgres related on AIX, and it was a pretty good platform. So this number is pretty surprising that it's that wildly different. But it might also be a thing to consider. If you're on AIX and thinking you want to stay on Power, maybe then it's time to look at a different operating system. And arguably, IBM has come to that conclusion on their own as well for different things. So just be aware of that. So conclusion on sort of the first round of benchmarking, and this is what we really wanted to be sure of, right? Is OpenPOWER actually a platform that you could feel comfortable building on, right? That if you were going to move stuff, maybe you didn't want to change architectures or whatever the reason was, you want to take advantage of it, yes, you could do that with Postgres, right? We feel like it's pretty solid, the support is there, and you can build on top of that. There are some different ways you can kind of approach that problem, and so, it does depend, do you want to do like virtualize on top, or do you not want to do that? Again, Linux versus Unix and things you can look at. But by and large, we can get very good performance numbers on this platform in this combination. So that was our first conclusion from a couple of years ago. So earlier this year, we got to do some more benchmarking on Power 9, so we kind of wanted to show a little bit of that, just to kind of see what the difference was. Was there a difference? Was it still improving, or was it flatlined or whatever? And so this is Power 9. Again, this was done earlier in the year. We also used newer Postgres because we wanted to see what the effects were of that. It's not exactly the same hardware. This is one of the issues Not everybody has a bunch of power equipment lying around that they can just give away, for let you use for years and years. So we did try to keep some things the same, but the disclosure, it is a little bit different. Different packages that were used. We did kind of try to stay on the 9.6, because that's what we had used before, but we did look at newer version as well. The other machine. So in both cases, we use SSD on the bottom end, which also makes a big difference. Certainly, you would probably want to do that if you're doing heavy data crunching. That's nothing terribly surprising. It's not a power thing. That's just a database thing. Here we used Red Hat for the OS piece to get a look at that. And we did have a patch for Power 9 optimized packages. So we think that may have helped a little bit as well. From the tuning side, we did tune the operating system a little bit. And this is one of the things that it's, I wouldn't say this is heavily tuned because it's benchmarking. You need it to be quick and repeatable. But we did do a few things that we thought would actually improve the performance and typically have, in customer settings that we have and that kind of thing. So we had some basic guidelines, at least to get rid of like the obvious things that you would want to do. So, and again, feel free to reach out. We can get you more details on all of the stuff that we've done. It's for lack of time to go into all the details of it. But again, we use PGBench as sort of our base benchmarking tool here. Did the TCP scalability benchmark just to sort of look at that, right? So very similar type of benchmarking. Here's the read-only performance. So this was, again, sort of the initial one that I showed you first. It was like select only. It's kind of the most basic test you can do. Here we're doing Postgres 11 versus Postgres 9.6. So 11 was released about, I think it was October or November of last year. So about a year old. So 11 was essentially the stable, release at the time we were doing this. If I gave this talk a month earlier, then it would have been the stable release. So the numbers aren't wildly different. You see a little bit of improvement. These are actually on the same hardware to compare the versions of Postgres to see. And we do expect them to be better with the newer version, and it was, so that was good. We felt at least it sort of proves we're going in the right direction here as we look at different things. Here we go back to running the SMT scaling test to see, does that matter, 1 versus 8 core and how that's working. And it's interesting to me, you expect it to be better. So, again, you can look at it. 8 is up here, right, on the PG11. Not sure how well you can see that. So this is all Postgres 11. But when we did 4 with the MPCT down here, it's at 4. So it gets better like you would expect. It's not really like surprising or anything. It's what you would hope to see from it. And, most of this is like, how do you shake out the outliers? Because we've certainly seen in architectures, and this is like Intel as well, and probably more so on the Intel side, depending on what you do. You turn hyper-threading on, maybe you have like a 32-core box, and it's like, we're going to hyper-thread this up to like 128, and like the performance goes in the tank, right? Like it doesn't quite work. So you're trying to sort of see like, where does this stuff actually work out, and can it work better, and that type of thing. It's also important to remember, I didn't mention this at the beginning, so for those that don't know, Postgres is very process-based. Whenever you make a connection into Postgres, it actually forks a new process on the operating system side. So everything it's sort of safer to do that than to do multi-threading, but it also changes sort of the performance dynamics a little bit. And even when Postgres is parallelism, like if it's doing parallel query, in that query it's taking that workload, splitting that off into multiple processes, and then gathering it back. So that's something to keep in mind, that the number of processes, the number of cores you have and how that works is definitely important. Here again, sort of with some more tuning and sort of looking at it here, we sort of up the number of cores that we're going to work with. And so, hey, guess what? More cores, better performance. Again, what you're kind of hoping to get out of the system to see that you're going in the right direction. Now, we did look at this, and there were some things that were a little bit odd. Here was one that we had. This was around the time of Meltdown Inspector, and we wanted to look at like, hey, if we change the number of clients, that's one thing you have to be aware of when you're doing this benchmarking, especially with PGBench. How you set that up can really make a difference. If you put PGBench on the same machine as the database server, that can saturate the database server because there's all these clients that are connecting and trying to do all this work. In a way that would be different if you did PGBench on a different machine, right? And then sometimes you have to spread PGBench across multiple machines. So we played around with that to see, do we get different numbers? Are they wildly different? Here, they weren't wildly different, although you could see you could get better performance. And here we were changing some of the kernel defaults. Here was Power with 22 core, scaling up to 600 clients. We think we hit a bottleneck actually outside of the server. And again, this was maybe with our PGBench setup. So because of where it peaked and how the performance stayed so steady, when you see that steady of a line, you just sort of look at like, maybe we've hit some kind of limit someplace that we weren't expecting. One thing that we did also look at is CPU balancing, as far as like, moving processes and jobs around. We think there's work to be done there. And again, just for time reasons, won't go too deep into this, but we were able to play around with this and see, based on the number of clients that we had that were connecting, we could get different performance out of it. Again, that's what you would hope for if the system is working the way that you would expect it to. But then you just have to account for how do the clients connect? Are they all, one machine, multiple machines, and how do you deal with that type of a problem? There's more actually graphs that we would like to do or could have done. Some were definitely on the kernel side, right, and try to do like CPU affinity. We did a little bit of work on that to see where we could get things to go. Here, it worked out really well in one case. I think in the other one it didn't actually work, which is why the graph ends up being like you only get to see one half of the picture. But we were able to improve latency of the system as a whole as we were tuning that type of work. So that was definitely useful. And then going back to this concept of process switches, right? If we could have more affinity, could we get it to perform better? It did seem like we could get it to perform better early on, but as that scaled, actually, then that performance difference kind of went away, which we thought was interesting. And we had this really interesting graph on CPU usage, that this one, like we just stared at it for a long time and scratched our heads and got, again, suspicious that somewhere in PGBench land, we've hit a bottleneck for that. So, lots of things like that. I'm going to skip through a few of these. I did want to talk a little bit about migration. Again, here we did some testing Power VM versus VM ESX, and just wanted to look at some different versions of that. To me, the most important thing on looking at most of these graphs as you're looking at them, one is that most of what is here is read. This next one is read-write. You see, usually it's similar performance curves, which is good. And even in the cases where, like, these numbers are fairly different between the two. This is a 9.6 to Postgres 11. So even though those numbers are fairly different, it's, in most cases, as you're looking at this, it's a version makes the numbers better, as you get newer versions. More cores makes the numbers better, and performance characteristics tend to make sense for the most part. So, here's maybe the last one. So this is DBT3. So this is more data warehousey type workload. And then just looking at like perf output versus OpenPOWER perf throughput. So just wanted to get another sort of look at, number of workers again, and is it always better? And in this case, this is not an unsimilar profile to what you might see on an Intel architecture. As you scale the number of CPUs with Postgres, you sort of hit a limit. And it seems to be for every operating system. Where the number is different. And there's work on the Postgres community side of like, how do we get that to be larger and larger for everybody? But as that number gets bigger, it's diminishing returns, but still better, which is what you would want to have. So yes, benchmarks, all in all, conclusion, right? So they prove the platform is stable. We know it can be done. And now we've seen the results of year-over-year work within the platform has improved the platform itself. Again, we scale pretty well on Power and Linux as a combination, and I think there's more that could be explored in that, comparative to if you want to run an Intel or something else. And certainly if you want to do a full OpenStack type of thing on Postgres, or OpenStack on Power, and you want to use Postgres as part of that, there's not really too much reason not to do that. You may want to lean heavier on, professional support of some type, depending on how deep your particular knowledge is in this platform. We didn't see this in the benchmarking, which is good. Customer work, we have some customers that use Power, so we have seen the odd thing, and I think we find that anytime when you're working on something that's just not as mainstream, whether it's an operating system or architecture, every now and then you will hit a really weird looking bug, and then it's like, what is this? And a typical user hopefully won't have to troubleshoot that kind of a thing. So you just have to be aware of that. If you're trying to migrate off of x86 over to Power, that's actually, it's relatively easy or not much more complicated than it might be for other migration problems. If you can do dump and restore of your data, that's really easy and that always works. If you're in Postgres, anything newer than 10, there's logical replication, which essentially is doing a rewrite of the data in a non-binary format, so that works pretty well. We've done testing with physical streaming replication. For the most part, this seems to work. If you are, let's say you're going from like, a Debian to a Debian, there are some issues that you can run into. Binary copy of data files obviously becomes questionable. And actually the scariest part is that it looks like it works. And so then you may not realize that something's broken until you got into production. So we've seen that problem, and it's hard to trace that back. And then just looking at sort of physical migration, again, it's sort of the same thing. There's locale issues. That's one of the problems of if you switch operating systems in the middle of this, then things like indexes might be slightly different because locales have been updated. And so you have to deal with that kind of a problem. So, but again, dump restore is usually a good way to go. Just reindex things. If you're going that route where you're not doing the dump and restore, you can reindex the indexes and get through it. You just have to account for it. So if you have more complex things than that, we're happy to help. There's good community resources, I think, in general. And most of that stuff is not actually that power specific. So there's just general problems around that. So I'm at the end of the time. So thanks, everybody. And for those that came, hopefully that was useful and you have a better understanding. Again, happy to try to answer questions. I don't know,
we're near the end. But I will say, back to your graph of AIX GCC.
Yep.
Your observation there is probably more correct, that GCC is likely the bottleneck on AIX. It does not get a lot of care and feeding. That environment can be a little touchy. XLC is where the compiler work generally is there. So, not saying AIX. I'm confirming your suspicions that graph might look artificially bad.
If it looks really odd, that's probably a good reason.
Yeah. Great talk. Anybody have questions for Robert? All right. Then thank you very much. Let's give him a round of applause.
Thank you.